Today, we're diving into a piece of industrial hardware that, looks pretty simple on the surface, but its design can have some absolutely massive, multi-million-dollar consequences. We're talking about ladder cable trays, and we're going to break down exactly when they go from being just another option on the table to an absolute non-negotiable necessity. First, I just want to put a number up here, 2.3 million yen. So what do you think that is? I mean, is it a marketing budget? Maybe a rounding error on a giant project? Nope. It's way more interesting than that. It is the direct result of one single critical engineering decision. And get this isn't some made-up theoretical number. That is the actual real-world savings on a project, all because the team decided to use a different kind of cable support. It's a perfect illustration of how infrastructure isn't just about making things work, it's about having a huge financial impact. And that story brings us to the Shandong petrochemical expansion project back in 2023. So we're going to dig into this case study to see exactly how a choice that seems pretty minor on the surface totally changed the financial outcome of the entire project. So let's get into the specifics. You've got this massive project. We're talking 12 kilometers of cable that needs to be routed. And the big challenge? All these heavy, high-voltage cables. The solution, though, was surprisingly simple. They just switched from a solid bottom tray to a ladder tray. And that one move, that single change, let them use a smaller, less expensive copper cable, which led directly to that $2.3 million in savings. So that's the million-dollar question, right? Or, well, the 2.3 million yen question. How does a simple frame of metal rungs and rails pull off something so significant? Well, the answer isn't what you see at first glance. It's all about the engineering and the physics hidden in its design. To really understand the how, we have to look at the anatomy of the ladder tray itself. And trust me, it is all about the geometry. So let's break down where all that incredible performance really comes from. So at its core, this is what we're talking about. It's incredibly simple. You've got two side rails running down the length, and they're connected by these cross pieces or rungs, just like a ladder. It's a really elegant, simple design, but that simplicity is hiding some seriously clever structural thinking. Now, let's put this side by side with another common choice, the perforated tray. See, the ladder tray uses those two strong side rails to carry all the weight, focusing the load right there. But the perforated tray, it spreads that load out across the entire bottom sheet. It's just a fundamentally different approach to handling stress. And here's the key. This is the secret sauce. Those side rails on a ladder tray, they act just like the I-beams you see in buildings. All their strength is concentrated vertically, which gives them this incredible power to resist bending over long distances without adding a ton of extra weight. That's what gives them a way better load-to-weight ratio. And the numbers? Well, they speak for themselves. A ladder tray can typically handle 2, even 3 times the load of a perforated tray. We're talking up to 200 kilograms per meter. And notice the side rail thickness, too. Those beefier rails are what make it all possible. But look, strength is only half the battle. Let's talk about the second huge advantage, the one that really ties back to our $2.3 million saving in Shandong, because it's not just about strength, it's all about airflow. This is just basic physics, right? As electricity runs through a cable, resistance creates heat. Now, if that heat has nowhere to go, the cable gets hotter and hotter, and that limits how much current or ampacity it can safely carry. If you trap too much heat, you have to use a bigger, much more expensive cable to do the same job. And this chart shows you exactly how that plays out. Engineers use what's called a derating factor to figure out a cable's real-world capacity. A perfect score would be 1.0. Now look at this. The open ladder tray lets cables run at 85% of their ideal capacity. But an enclosed tray, that drops all the way down to just 60%. That difference is enormous, and that's where the money is. It's really that simple. Because ladder trays let air move around freely, the cables just run cooler. And that means you can push more current through the same size cable without any risk. Or, like in the Shandong project, you can use a smaller, way cheaper cable to do the exact same job. That, in a nutshell, is the airflow advantage. Okay, so we've got incredible strengths and a huge thermal benefit. Now let's see how this all works in some other really tough, demanding places. From deep underground tunnels to salty, corrosive coastlines. Here's another number for you, 40 minutes. Now that might not sound like a lot, but believe me, in the world of infrastructure maintenance, 40 minutes is an absolute game changer. That's how much time maintenance crews saved on every single
10-meter section when they were swapping out cables in Beijing's utility tunnels. Because the ladder tray is open, they don't have to waste time pulling cables through long, closed-off pipes. They can get to it instantly, which slashes labor costs and downtime.
All right, let's go to a totally different environment. A coastal desalination plant in Oman. You can't get much more corrosive than that. With their old system, they had to do maintenance checks every single quarter. By switching to a super corrosion-resistant 316L stainless steel ladder tray, they pushed that out to just once a year. That's a 75% cut in maintenance. Huge.
And one last number. 150 kilograms per meter. Now that is a serious amount of weight. This was the spec required for the Chengdu Metro. They needed something that could, without a doubt, support the massive, critical cables for the signals and the train power, deep underground. When failure is simply not an option, that's when engineers bet on the structural integrity of a ladder tray. So, after looking at all the evidence, let's just bring it all home. When does the ladder tray stop being an option and become the only real choice? Here are the key things to remember. The decision becomes a no-brainer under these 4 conditions. Number 1, you've got really heavy cables hanging over long spans. 2, heat is a major concern, and you have to squeeze every last amp out of your cables to save money on copper. 3, you need to get in and out from maintenance fast. And 4, the environment is just plain nasty, and you need something that's built to last. If your project checks any of those boxes, the ladder tray is your answer. And that brings us to a final thought. You know, as our world demands more and more power, and as our existing infrastructure gets older, the choices we make about these basic fundamental components, they become more critical than ever. The next $2.3 million decision isn't years away. It's probably being planned right now, in a tunnel or a factory right underneath our feet.